Okay, welcome everyone. So today we are just going to continue our previous class. There was some issue related to the broadcasting in our previous class, so we are going to continue with it. I hope you enjoy our this class. So I'm going to continue from where we left yesterday. Okay, so I asked a question from you guys. Sorry. I asked the question from you guys and I have to answer it. So the question is, why does refraction occurs? Okay. So our question is कि रिफ्रैक्शन हो क्या हो रहा है. जनरल मोस्टली क्या आता है, तो कल अपन ये पढ़ चुके थे कि अगर लाइट रे एक मीडियम से दूसरे मीडियम में अगर ट्रेवल करती है तो वो अपने पास से क्या हो जाती है, डेविएट हो जाती है. और जैसे ही वो डेविएट हो जाती है इसका मतलब क्या पता चला कि लाइट रिफ्रैक्ट हो चुकी है. तो ये पढ़ चुके थे अपन कि अगर लाइट रे रेयर से डेंसर मीडियम में जाएगी तो लाइट नॉर्मल की तरफ बेंड हो जाएगी, और डेंसर से रेयर की तरफ जाएगी तो लाइट नॉर्मल से दूर की तरफ चली जाएगी. तो ये केसेस थे अपने जनरली फॉर द रिफ्रैक्शन. आज अपना क्वेश्चन था, कल कंटिन्यू कर रहा था मैं, सो देयर वाज एन इशू रिलेटेड टू दैट, तो आज इसे कंटिन्यू करते हैं. सो व्हाई डज रिफ्रैक्शन अकर, यहाँ पे एस लगा दिया, सॉरी फॉर माय बैड इंग्लिश. व्हाई डज रिफ्रैक्शन अकर. सो जनरली होता क्या है, यहाँ पे पढ़ तो अपन लाइट एज अ रे रहे हैं, बट लाइट में वेव का भी फीचर है, और वेव में फ्रीक्वेंसी होती है, वेव में वेवलेंथ होती है, वेव में स्पीड होती है, वेव में सब कुछ होता है. सो जनरली क्या होता है कि अगर लाइट एक मीडियम से दूसरे मीडियम में जाती है तो उसकी फ्रीक्वेंसी तो सेम रह जाती है, फ्रीक्वेंसी सेम रह जाती है, बट अदर देन फ्रीक्वेंसी एवरीथिंग चेंजेस. वी कुड से इट्स वेवलेंथ चेंजेस, everything changes, its wavelength changes, its velocity changes, and every other thing that is going to be changed by the light. So the refraction occur because the speed of light, because the speed of light vary, the speed of light vary from medium to medium. So generally what happens when a light ray is traveling from one medium to any another medium, so the speed of light will get vary from it. If a light ray is traveling from a rarer medium to denser medium, it will get slow. That's why it will move towards the normal. But if a light ray is traveling from a denser medium to a rarer medium, it moves away from the normal. सो व्हाट जनरली हैपन, जैसे ही लाइट ने मीडियम चेंज किया तो लाइट ने अपनी स्पीड भी चेंज की, और जैसे ही स्पीड चेंज की तो उसकी वजह से अपना क्या फिनोमेना हो रहा है, रिफ्रैक्शन अकर हो रहा है. सो व्हाट शुड बी आंसर रिलेटेड टू दैट इफ समबडी आस्क्ड द क्वेश्चन व्हाई डज रिफ्रैक्शन अकर. सो रिफ्रैक्शन अकर्स बिकॉज द स्पीड ऑफ लाइट वेरी फ्रॉम मीडियम टू मीडियम. Here medium is considered as an optical density. We are not considering it as a general density. We are considering it as an ऑप्टिकल डेंसिटी. तो कोई मीडियम ऑप्टिकल रेयर मीडियम होगा, कोई मीडियम ऑप्टिकल डेंसर मीडियम होगा. तो अगर लाइट रे रेयर से डेंसर मीडियम में जा रही है, सो लाइट गेट स्लो. इफ अ लाइट रे ट्रेवल फ्रॉम रेयर टू डेंस मीडियम, इट विल गेट स्लो. It will get slow. अगर denser से rarer में जा रही है, if it is moving from denser to rarer medium, it will become comparatively fast than the previous one. So why does refraction occur? Frequency remains same, but the speed of light vary from medium to medium. And if it is traveling from the rarer medium to denser medium, it will get slow. And if it's traveling from denser medium to rarer medium, it will become fast. I hope you understand the topic. Okay. So let me proceed after that. So we are going to learn about the basic laws of refraction. So basic laws of refraction. There was two laws of reflection. which we have already learned. The first one is the angle of incidence equals to angle of refraction, and the second one is at the point of incidence, incident ray, normal ray and the reflected ray are all lie on the same plane. In a transition phase we could say that, but the laws of refraction there is something different regarding to it. So सबसे पहला क्या है इसमें, at point of incidence, this one is like a same at point of incidence, incident ray, this is a T, sorry for that, incident ray, refracted ray and normal at the point of transition all lie on the same plane, are all lie on the same plane. This is our first law of refraction. So what is our first law of refraction? At point of incidence, incident ray, refracted ray and a normal at the point of, at the phase of transition are all lie on the same plane. So this is our just first law for the laws of refraction. But the second one is important law, and which is also going to be known as the Snell's law. Okay, so Snell's here propagates something related to the refraction. So Snell's here says that the ratio of sine of angle of incidence, what does the Snell say? The ratio of sine of angle of incidence with respect to the sine of angle of refraction, angle of refraction is always a constant, is always a constant. And here the constant is generally written as the mu. So the Snell's law is mu equals to sine I upon index. Here mu is also known as refractive index. There is a modified way of explaining the refractive index which we are going to learn further, and okay, I am going to explain it to you right now. So first of all, look at the laws of refraction. So what are the laws of refraction? First one is at point of incidence, incident ray, refracted ray and normal are all lie on the same plane in a transition phase. We are going to say in a transition phase when a right ray get refracted, that's why we are going to say that. But for the Snell's law, this is a different law. In the laws of reflection, there will always be that the angle of incidence equals to angle of reflection. But here in Snell's law, the ratio of sine of angle of incidence with respect to sine of angle of refraction is always a constant. And this constant is known as the mu, mu equals to sine I upon sine r, which we are going to say the refractive index. Now the things come. Suppose, let me clear it. Suppose mu equals to sine I upon sine r. This is the Snell's law. But what if I say that the incident ray fall normally at the surface, then the angle should be, if the incident ray, which we have studied earlier, that if a light ray travel from first medium to second medium, we could say that the first medium is a rarer medium and the second medium is known as the denser medium. If a light ray is traveling from rarer medium to denser medium, it will move towards the normal, or we could say it will bend towards the normal. But if a light ray incident at a particularly 90-degree angle, so the angle between normal and the incident angle will be 0. So here we are going to modify that I equals to 0, angle of incidence equals to 0. So what we will get? Mu sine r equals to sine 0. And what is the value of sine 0 degree? It's a 0 degree. It's a 0 value. So we could say mu sine r. Now here's the thing. This is our constant and its value could never be a 0. So what need to be a 0? Sin r. Sin r needs to be a 0. So if a light ray incident normally on a surface of any medium, if a light ray normally incident on a surface of any medium, it will not get refracted, और उसके पाथ में कोई भी डेविएशन नहीं क्रिएट होगा. It will not get deviated from its path. And here and at that point and here, Snell's law is not applicable. I hope you understand what I am trying to say. अगर कोई लाइट रे मींस 90 डिग्री से इंसिडेंट हो रही है सरफेस पे, इसका मतलब वो नॉर्मल के साथ कितना एंगल क्रिएट करेगी? 0 डिग्री क्रिएट करेगी. बट वी नो दैट द साइन 0 इज 0. सो हियर स्नेल्स लॉ इज नॉट एप्लीकेबल और लाइट रे में कोई भी डेविएशन नहीं होगा. ओके, आई होप यू अंडरस्टैंड इट. सो वी आर गोइंग टू नीड सम कंडीशन. तो स्नेल्स लॉ कब कब एप्लीकेबल नहीं होगा? पहला कंडीशन तो यही हो गई कि इफ अ लाइट रे इंसिडेंट होना नॉर्मली ऑन द सरफेस. सेकंड थिंग इज दैट द बोथ मीडियम आर कंपैरेटिवली रेयरर टू देमसेल्फ. मतलब दोनों का रिफ्रैक्टिव इंडेक्स, सॉरी फॉर द रिफ्रैक्टिव इंडेक्स, आई शुड नॉट से दैट वर्ड राइट नाउ व्हेन आई नॉट टीच यू. सपोज बोथ मीडियम्स आर द सेम, likewise same. If both mediums are same, then there will also not be a refraction occur. What I am going to say that the first medium and second medium are same optical depths. मतलब दोनों की ऑप्टिकल डेंसिटी कंपैरेटिवली सेम ही है, तो इस कंडीशन में भी रिफ्रैक्शन अकर नहीं होगा बिकॉज मीडियम नीड टू बी चेंज. सो व्हाट आई एम गोइंग टू से दैट अगर लाइट रे को ट्रेवल करना है तो उसको एक मीडियम से दूसरे मीडियम में जाना पड़ेगा फॉर द रिफ्रैक्शन. इफ इट इज ट्रेवलिंग फ्रॉम वन मीडियम टू अ सेकेंड मीडियम बट दोनों की ऑप्टिकल डेंसिटी सेम हो गई तो भी रिफ्रैक्शन अकर नहीं होगा. सो जनरली रिफ्रैक्शन कब कब अकर नहीं हो रहा? जब एंगल ऑफ इंसिडेंस कितना हो जाए? 0 डिग्री, और सेकेंड दोनों मीडियम की ऑप्टिकल डेंसिटी कैसी हो? सेम हो. सो इन दिस दोनों कंडीशन में रिफ्रैक्शन अकर नहीं हो रहा. आई होप यू अंडरस्टैंड इट. फिर से बता देता हूं, अगर एंगल ऑफ इंसिडेंस 0 डिग्री हो जाए मींस इफ द एंगल ऑफ इंसिडेंस इज 0 कंपैरेटिवली टू अ नॉर्मल. So if it falls normally on the surface, that's why the Snell's law is not applicable. You could see the math behind it. So there will be no deflection if the light ray incident normally on the surface. But here is also a second case. If a medium is not going to change, then there will also not be a refraction occur by the light and there will be no deviation regarding to it. Okay, I hope you understand when does the refraction not occur. Okay, I should move further regarding to that. So our next thing is the refractive index. Refractive index. Next thing is our refractive index. So generally refractive index are of two kinds. First one is absolute refractive index. Absolute refractive index. Now the thing is I have already told you about अगर लाइट रे कोई मीडियम से दूसरे मीडियम में जा रही है तो उसकी स्पीड क्या हो जाती है? वेरी हो जाती है. रिफ्रैक्टिव इंडेक्स भी कुछ इसी तरीके से रिलेटेड है. सो रिफ्रैक्टिव इंडेक्स इज आल्सो रिलेटेड टू द स्पीड ऑफ लाइट विथ रिस्पेक्ट टू वन मीडियम टू द अनदर मीडियम. बट वी आर गोइंग टू टॉक अबाउट द एब्सोल्यूट रिफ्रैक्टिव index. So what is the absolute refractive index? So first I am going to elaborate it, then I am going to write it. So here we need to consider one medium as a air or vacuum. So our one medium is going to be fixed. Here we could take anything, glass, water, oil, anything at all. Here we could take anything, but we need to consider one medium as air or vacuum. So here comparatively air and vacuum are the rarest medium. Right now we have known about it. I don't know if anyone known about the rarest medium than air or vacuum. I just have no knowledge right now, so I could say right now for it that the air or vacuum are the rarest medium compared to the other medium. So when a light ray travel from a rarer medium to the intermedium, its speed will change. What generally happen? that it will bend towards the normal. So we could say, यहाँ पे अपन ने स्नेल्स लॉ पढ़ चुके हैं. स्नेल्स लॉ क्या था अपना? एंगल ऑफ इंसिडेंस, साइन ऑफ एंगल ऑफ इंसिडेंस अपॉन साइन ऑफ एंगल आर is always a constant. So here we could say absolute refractive index. We could say here the ratio of speed of light in air or vacuum with respect to speed of light in any other medium. We are just going to compromise this relation with only two mediums. So one need to be air or vacuum and the second one is our glass. So, and as in assume that the speed of light is considered to be c, and c value is 2.998 10 raised to power 6. I could not say, 10 raised to power 8 meter per second. Sorry for the disturbance. It could be wrong. I have just not a complete verification regarding to it. So we are going to consider the speed of light in one medium at air or vacuum as a c, and the speed of light in any other medium as v, which we have no knowledge regarding to that. So it will also be a constant. So we are going to say the ratio of speed of light in air or vacuum with respect to speed in any other medium is also a constant. Here we are also going to use the same symbol, mu equals to c upon v. So this is our thing. So mu equals to c upon v. Generally what happens that every other refractive index is going to compare with the speed of light of air or vacuum, और इसकी value हमेशा 1 से ज़्यादा होगी, even if we are going to take the rarest medium. Other than those two, we are not going to take those two with respect to themselves, because the refraction will not occur. We have already discussed about it. If we need a refraction, we need to consider different mediums. If we are taking same medium, then there will be no refraction and there will be no Snell's law. But if the mediums are changed, then there should be a Snell's law. So what I am going to say, what is the absolute refractive index? The ratio of speed of light in air or vacuum, here I have written of air or vacuum. Sorry for the error earlier. The ratio of speed of light in air or vacuum with respect to speed in any other medium. So is always a constant. I have not written it, but I am going to say it again and again. Is always a constant. So here is constant is known as the mu. This is our refractive index constant. So mu equals to c by b. So we could say that the refractive index. So first one is our absolute refractive index when we are going to compare the ratio of speed of light with in air or vacuum with respect to speed in any other medium. So mu equals to c by v. Okay. So we should move to the second one. Second one is our relative refractive index. Relative refractive index. So here we are just going to omit that the speed of light in air or vacuum. Here we are just going to consider two medium. Suppose we are going to consider one medium as a glass and second medium as a water. We could consider those kind of same medium. Here the density of glass is more than the density of water, but it depends on the material of glass. So we are just going to compare that the glass is more denser than the water. And here is only a little bit of a difference between the density of glass and water, but if it is a difference in a density, we are going to say about the optical density, not a general density. We are going to say about optical density. So there should be some difference related to their optical density. तो उसकी वजह से क्या होगा? Refraction occur होगा. So here we are going to compare glass as a denser medium and water as a rarer medium. So when a light ray travel from a rarer medium to a denser medium, it will move away from the normal. So we are just going to say that the speed, the ratio of speed of light with respect, oh sorry, the ratio of speed of light in one medium to with respect to any other medium. तो सपोज कर लो ग्लास में स्पीड ऑफ लाइट हो गई v1 और वाटर में हो गई v2. So we are going to say that the mu equals to is always a constant that has to be written, but I just forget about it, so I'm just going to say that the mu is going to be written. So here we could say that I'm going to represent its glass mu air. So the first one is where the angle of incidence are, so we could write first one is here, and the second medium with respect to that will be going to write at the prefix. So glass mu air is going to be written like this, v1 upon v2. इसकी वैल्यू कुछ भी हो सकती है, उसकी वैल्यू हमेशा बहुत ज्यादा होनी चाहिए, बट इसकी वैल्यू डिपेंड करती है, इट्स अ सब्जेक्टिव मैटर. तो हियर यहाँ पे कुछ भी हो सकता है. So for the relative refractive index, we are going to say that the ratio of speed of light in one medium with respect to the any other medium is always a constant. I am going to refer it as glass mu. I have written A. It should be glass mu water because it's a water. Sorry for that. So glass mu water equals to V1 by V2. So this is our relative refractive index. So again, listen to me. There are two kinds of a refractive index. First one is our absolute refractive index. In our absolute refractive index, we are going to say that a speed of light in one medium, which is always has to be air or vacuum, and the speed of light in any other medium is always to be a constant. और उसकी वैल्यू हमेशा 1 से ज्यादा होगी because air और vacuum are the rarest medium. So उसकी वैल्यू हमेशा 1 से ज्यादा होगी if we are not going to take the same medium, because same medium लिया तो रिफ्रैक्शन होना ही नहीं है. सेकंड थिंग इज आवर रिलेटिव रिफ्रैक्टिव इंडेक्स. तो यहाँ पे अपन कोई भी दो सब्जेक्टिव मीडियम ले सकते हैं जिससे अपना रिलेटिव रिफ्रैक्टिव इंडेक्स निकल सकता है और उसकी स्पीड ऑफ लाइट को अपन कंपैरिजन करते हैं. ये स्नेल्स लॉ का मॉडिफाइड वर्जन है. ओके, आई होप यू अंडरस्टैंड इट. सो देयर आर टू काइंड्स ऑफ स्नेल्स लॉ. म्यू इक्वल्स टू sin i upon sin r, or mu equals to speed of light in one medium with respect to speed of light in any other medium. So these are the general relation for the refractive index. Now we are going to learn about the dependency of refractive index and what are the factors that are going to affect the refractive index. There are so many mosquitoes there. I am sorry for. Okay, this one is on our board. So dependency of refractive index. Dependency of refractive index. So first one we are going to consider subjective medium. So dependency on medium. So this is the most important thing, dependency on medium. So if a medium is going to change and if the medium is not going to change, there will be no refraction. So the refractive index depends on the medium density. But we are not going to say about the density right now. We are just going to say that the dependency on medium. So if our refractive index is comparatively to if it is traveling from rarer to denser, so it's always be more than 1. And if it's traveling from the denser medium to rarer medium, it should always be less than the 0. So the medium has to be dependent for the refractive index. And the second thing is dependency on density. Dependency on density. So if a medium is more denser, here we are going to consider density related to optical density. So if a medium is more denser or less denser, so it will also reflect on the refractive index. अगर यहाँ पे अपन comparative कर रहे हैं, एक ज़्यादा higher optical denser है और एक lower optical denser है. Higher optical denser में diamond. If we are going to compare anything, so the diamond having the highest optical density comparatively to the air, and its value approximate 2.33 around. I have no knowledge related to that exact knowledge. I am not going to say that I have no knowledge. I'm just going to say that the constant is getting the same value or not. But here we are going to consider the optical dependency on density. That diamond is the highest optical dense material right now. I have having a knowledge regarding to it comparatively to air. I am not going to say about any other medium. So diamond and air has a refractive index related to mu equals to 2.33. So this is our second factors. Now the third one is our dependency on temperature. Dependency on temperature. As we increase the temperature, जैसे जैसे अगर अपन टेम्परेचर को इंक्रीज करते जाएंगे तो मॉलिक्यूल्स दूर दूर होते जाएंगे. अगर मॉलिक्यूल्स दूर दूर होते जाएंगे तो जो मीडियम है वो अपना कैसा होता जाएगा, रेयरर होता जाएगा और रिफ्रैक्टिव इंडेक्स की वैल्यू गिरती जाएगी कंपैरेटिवली. तो जैसे मीडियम डेंसर होगा तो रिफ्रैक्टिव इंडेक्स भी ज्यादा होगा और जैसे मीडियम कम होगा रिफ्रैक्टिव इंडेक्स भी कम होगा. नाउ द थिंग डिपेंडेंसी ऑन द वेवलेंथ. Last one is dependency on wavelength. On wavelength. So here's something I forget about to say to you, but I'm going to say it again. For the refraction, we are just going to consider a monochromatic beam. What does a monochromatic beam means? Monochromatic beam. Sorry, I'm going to fumble it a lot. Monochromatic beam means a wave which is having a singular wavelength. जिस लाइट वेव की वेवलेंथ कैसी हो, सिंगुलर हो, मतलब एक से ज्यादा वेवलेंथ ना हो, तो उस वेव को अपन मोनोक्रोमेटिक बीम कहते हैं और मोनोक्रोमेटिक बीम ही लेते हैं अपन फॉर दी रिफ्रैक्शन. सो हियर वी आर गोइंग टू से डिपेंडेंसी ऑन वेवलेंथ. सो हियर द फेमस साइंटिस्ट नेम Cauchy has give dependency of refractive index. So his formula is mu equals to a plus b by lambda square. So he just give the relation. This is our Cauchy formula. Here a and b are the constant and here you could see that the lambda is a wavelength. So if these are the constants, so we could say mu inversely proportional 1 upon lambda square. तो अगर वेवलेंथ ज्यादा होगी तो रिफ्रैक्टिव इंडेक्स क्या होगा, कम होगा, और वेवलेंथ कम होगी तो रिफ्रैक्टिव इंडेक्स ज्यादा होगा. जनरली वी नोन अबाउट दैट द रेड कलर हैज द wavelength comparatively to the more order. So what will happen, that the refractive index of red color is less comparatively to the other color, and the wavelength of violet color, we could say wavelength of violet color is comparatively lesser than the wavelength of red color. So if the wavelength of violet color is less, then its refractive index should be more than the red color. Sorry, why I am going to fumble a lot. So we have learned about the dependency of refractive index. So the first one is dependency on medium. जैसे मीडियम्स होंगे उसके अकॉर्डिंग रिफ्रैक्टिव इंडेक्स डिपेंड करेगा. अगर रेयर से डेंसर जाएगा तो मीडियम, रेयर से डेंसर अगर मीडियम होगा तो अपना तो रिफ्रैक्टिव इंडेक्स की वैल्यू भी ज्यादा होगी. अगर डेंसर से रेयर होगा तो रिफ्रैक्टिव इंडेक्स की वैल्यू कम होगी. डिपेंडेंसी ऑन डेंसिटी, अगर अपन हाईएस्ट ऑप्टिकल डेंसिटी ले रहे हैं कंपैरेटिवली टू लोएस्ट ऑप्टिकल डेंसिटी तो अपने पास रिफ्रैक्टिव इंडेक्स की वैल्यू ज्यादा मिलेगी. अगर लोअर ऑप्टिकल डेंसिटी ले रहे हैं कंपैरेटिवली टू हायर ऑप्टिकल डेंसिटी तो रिफ्रैक्टिव इंडेक्स की वैल्यू कम मिलेगी. फिर बात आती है डिपेंडेंसी ऑफ टेम्परेचर. जैसे जैसे टेम्परेचर इंक्रीज करते जाएंगे वैसे वैसे मीडियम रेयर होता जाएगा और रिफ्रैक्टिव इंडेक्स गिरता जाएगा. उल्टा भी कर सकते हैं, टेम्परेचर कोल्ड कर सकते हैं अपन, टेम्परेचर टेम्परेचर है, इट कुड बी इंक्रीज इट कुड बी डिक्रीज. अगर ठंडा करेंगे तो फिर से बढ़ जाएगा. ओके, नाउ द थिंग इज डिपेंडेंसी ऑन वेवलेंथ. सो वेवलेंथ पे कैसे हैं, इनवर्सली प्रोपोर्शनल टू द लैम्डा स्क्वायर. जिसकी वेवलेंथ ज्यादा उसका रिफ्रैक्टिव इंडेक्स कम, जिसकी वेवलेंथ कम उसका रिफ्रैक्टिव इंडेक्स ज्यादा. So the more the wavelength is, the refractive index should be more. The less the wavelength is, the refractive index should be less. Okay, thank you everyone for this class. I hope we will meet again.